Sixth grade, Module 5, Lesson 19 problem set. Solve each problem below. Number 1. Dante built a wooden cubic toy box for his son. Each side of the box measures 2 feet. So it's a cubic toy box, so each side is 2 feet. So it's a cube, which is nice, so all the sides are the same length. A. How many square feet of wood did he use to build the box? And B. How many cubic feet of toys will the box hold? So A is asking us to find the surface area because we want to know how many square feet of wood he used to build all the different faces of the box. Whereas B is asking how much it can hold, and so that's talking about volume. So let's start with the surface area. And to find surface area of a cube, all we have to do is do the 6 times the side length squared. So let's do 6 times 2 squared. So 6 times 2 squared is 4, would be equal to 24 feet squared would be the surface area. So it can hold, so that's A, 24 square feet. To build square feet of wood to build the box. And then B wants us to find the volume. So if each side is, so volume is length times width times height. So if all the sides are 2 feet by 2 feet by 2 feet, that would be equal to 2 times 2 is 4, times 2 is 8 feet cubed, so it can hold 8 cubic feet of toys. So the box would hold 8 feet cubed of toys. Or you could write it out. You could write 8 cubic feet. Either one. All right, number 2, a company that manufactures gift boxes wants to know how many different sized boxes having a volume of 50 cubic centimeters it can make if the dimensions must be whole centimeters. A, list the possible whole number dimensions for the box. So we're listing the possible dimensions of volume, so length times width times height, that would get us 50. So like in the classwork, I'm going to start with choice 1, and I'm going to do 1 by 1, let me write feet, 1 foot or centimeter, 1 centimeter by 1 centimeter by 50. And then choice 2, let's keep going, we could do 25 times 2, so let's do 1 centimeter by 2 centimeters by 25 centimeters, because that would get 50. So we're looking for 3 things that multiply to get 50. So let's keep going. Let's see. What else let's see. 5 times 10 is 50. So we could do 1 times 5 times 10. So 1 centimeter times 5 centimeters times 10 centimeters. And then I can break this down even more. We could do 2 times 5 instead of 10. So we could do choice 4, we would have 2 centimeters times 5 centimeters, so that's 10. And then we would need to multiply it by another 5 centimeters, that would be 50. And then we can't factor these down anymore, so that is going to be it for our choices. Okay, so B says, which possibility requires the least amount of material to make? So finding the surface area, because we want to know how much material we have to make. So let's find the surface area of each of them. So this would be, remember the volume area, or the equation for surface area is length times width, or two groups of those, plus 2 groups of width times height, plus 2 groups of see, length times height. So, and in any order. So I'm going to do 2 times length times width, 1 by 1, plus 2 times 1 by 50, plus 2 times 1 by 50. So we would have 2 times 1 would be 2 centimeters squared, plus 1 times 50 is 50, times 2 is 100 centimeters squared, plus another 100 centimeters squared. So that would get us 202 centimeters squared for choice 1. Choice 2, I'll do in green. So that was 1. 2 would be 2 groups of 1 times 2 plus 2 groups of 1 times 25 plus 2 groups of 2 times 25. So we have 2 centimeters squared plus 25 times 2 is 50 centimeters squared plus 50 times 2 is 100 centimeters squared. So that is 152 centimeters squared. Actually, I did this one wrong. 1 times 2 is 2. 2 times 2 is 4. So this should be 4. So I always check your work, because even small things like I said 2 times 2 is 2. So really important to check your work. Glad I looked back at that. 154 centimeters squared. Okay, let's do choice 3. Okay, so we have 2 groups of 1 times 5 plus 2 groups of 1 times 10 plus 2 groups of 5 times 10. So 1 times 5 is 5, times 2 is 10 centimeters squared, plus 1 times 10 is 10, times 2 is 20 centimeters squared, plus 5 times 10 is 50, times 2 is 100 centimeters squared. So this would be equal to 130 centimeters squared. And then the last one, choice 4. We have 2 groups of 2 by 5 plus 2 groups of another 2 by 5 plus 2 groups of 5 times 5. So basically just go through and I match them. So I match that one to there, and then I match that one to there, and then these 2 are the only ones that haven't been matched. So I just pair them up with, make sure everyone is paired up, basically. So we get all the sides. So 2 times 5 is 10, times 2 is 20 centimeters squared, plus another 20 centimeters squared, plus 5 times 5 is 25, plus 50, or 50, 25 times 2 is 50 centimeters squared. So that would be equal to 90 centimeters squared. Okay, let's go back and see what the question was asking again, because we have all the surface areas. So which possibility requires the least amount of material? So we're looking for the least amount of these. So that would be 90 centimeters squared. So our choice 4 requires the least amount of materials to make. So which box would we recommend the company to use? Let's see. It wants to know how many different size boxes having a volume of 50 cubic centimeters if it can make if the dimensions must be whole centimeters. So which one do you think they should use? I would use the choice 4 because it requires the least amount of material. So that's going to be probably the most cost effective for them. So let's say I would choose 2 centimeters by 5 centimeters by 5 centimeters because it has the smallest surface area and would take or would use the least amount of materials? Let's say which would save money. Number 3, a rectangular box of rice is shown. What is the greatest amount of rice in cubic inches that the box can hold? So we want to know how much it can hold. So we're finding surface area or volume. Which one finds out how much it can hold? That would be volume. Remember, volume is length times width times height. So our length would be 15 1/3 inches times our width is 7 2/3 times our height is 6 1/3. So it's basically we're just practicing multiplying fractions here. And so you can make them improper fractions and multiply them out. Let's go ahead and do that. So 15 times 3 would be 45. So this is 46 thirds times 7 2/3 would be equal to, 21, 22, 23 thirds times 18, 19 thirds. So 3 times 3 times 3 is 27. So 46 times 23. Is 1058 times 19. Nine times 5 is 45, plus 7 is 52. That would be 5 and 9. Put our 0 down. Now we're just multiplying y1. So we get 20,102 27ths. Just a very large improper fraction. So let's divide that. 20,102 divided by 27. So it can't go into 20. It could go into 201. Let's see, 27 times 10 would be 270. So maybe like 27 times 7 or 8. Let's try times 7. 14, that's 18, 189. Yeah, another one will be too big. So it goes in 7 times. (11 minus 9 is 2. 9 minus 8 is 1. Bring down the 0. How many times could 27 go into 120? Maybe probably 5 times, because 27 times 7 was 189. So let's try 27 times 5. Oh, it's too big. So let's try 27 times 4. (108). So it goes in 4 times. 120 minus 108 is 12. Now we have 122, which we already know 27 times 5 was too big. So it can only go in 4 times again. And that is 108. Minus 8 is 4. So we have 14 left over out of 27. So 744 and 14 27ths. And that cannot be reduced. So that's equal to 744 and 14 27ths inches cubed is the volume of that. Number 4. The Mars Cereal Company has 2 different cereal boxes for Mars cereal. The large box is 8 inches wide, 11 inches high, and 3 inches deep. The small box is 6 inches wide, 10 inches high, and 2.5 inches deep. how much more cardboard is needed to make the large box than the small box? And how much more cereal does the large box hold than the small box? Okay, so we need to find the surface area to figure out how much more cardboard is needed. And then we're going to need to find the volume for each of them to figure out how much more the large one can hold than the small one. So the large box, let's start with large, was 8 inches by 11 inches by 3 inches. So let's find the surface area. Would be 2 groups of 8 by 11 plus 2 groups of 8 by 3 plus 2 groups of 11 by 3. So 8 times 11 is 88. 88 times 2 is 176 inches squared, plus 8 times 3 is 24, times 2 would be 48 inches squared, plus 11 times 3 is 33, times 2 is 66 inches squared. So let's add 48 to that. $224 plus 66 is 290 inches squared for the surface area. And then let's go ahead and find the volume so that we can just compare them all. So 8 times 11 is 88. Times 3, let's do 88 times 3. 3 times 8 is 24, plus 2 is 26, would be 264 inches cubed for the volume. So that's the large box. Now let's do the small box. Start with the surface area. So the small box is 6 inches by 10 inches by 2.5 inches. So we would have 2 groups of 6 by 10 plus 2 groups of 6 by 2.5 plus 2 groups of 10 by 2.5. So 6 times 10 is 60, times 2 would be 120 inches squared, plus 6 times 2.5, let's see, 12, so that's 15, that would be 15, because we have 1 digit behind a decimal point, times 2 is 30 inches squared, plus 10 times 2.5, one digit behind a decimal point is 25, times 2 would be 50 inches squared. So add all of that together. 30 plus 50 is 80, plus 120, that would be 200 inches squared for the surface area of the small one. And then the volume would be equal to 6 inches by 10 inches by 2.5 inches. So 6 times 10 is 60. Let's do 60 times 2.5. And 1 digit behind the decimal point. So that's equal to 150 inches cubed as the volume. Okay, so now we have all the information we need to figure it out. So how much more cardboard is needed to make the large box than the small box? So to make the large, it was 290. To make the small, it was 200. So 290 minus 200 is 90 inches squared more cardboard. And then B, how much more cereal does the large box hold than the small box? So the large box holds 264 inches cubed. The small box holds 150. So 264 minus 150 is 114. So let's say 264 minus 150 equals 114 inches cubed more cereal. All right, number 5. A swimming pool is 8 meters long, 6 meters wide, and 2 meters deep. The water-resistant paint needed for the pool costs $6 per square meter. How much will it cost to paint the pool? Okay, so we need to paint. Let's kind of draw a pool here. Okay, so pretend that's a pool. And we have water inside, right? So a pool has all the faces covered except the top, right? Because if the top was covered, then you couldn't get in the water. So how many faces of the pool do you actually have to paint? You'd only need to paint the sides. So the 4 sides and the base, the bottom. So 5 faces because the top is just the water. How much paint in square meters do you need to paint the pool? So it was 8 meters long, 6 meters wide, and 2 meters deep. So how much paint in square meters do you need to paint the pool? We only need one of the base, so 8 meters by 6 meters. Plus we have 2 groups of the, let's see, the front and back faces here. So that's 8 by 2. And then the sides, we have 2 groups of the sides also. That's 6 by 2. So 8 times 6 is 48 meters squared, plus 8 times 2 is 16 times 2 is 32 meters squared, plus 6 times 2 is 12 times 2 is 24 meters squared. So let's do 48 plus 32. 80 plus 24 would be 104 meters squared of paint to paint the pool. How much will it cost to paint the pool? So it says it costs $6 per square meter. So we have 104 meters squared. We need to multiply that by $6 per square meter. So 104 times 6 would be $624 to paint the pool. Number 6. Sam is in charge of filling a rectangular hole with cement. The hole is 9 feet long, 3 feet wide, and 2 feet deep. How much cement will Sam need? So he's filling it with cement. So that means we need to fill it up. How much can it hold? So we're going to find volume. So the volume would be equal to 9 feet times 3 feet times 2 feet. So let's see. Let's do 3 times 2 is 6. And 9 times 6 is equal to 54 feet cubed. So he needs, let's say Sam will need 54 cubic feet of cement to fill the hole. Number 7, the volume of box D subtracted from the volume of box C is 23 and 14/100 cubic centimeters. Box D has a volume of 10 and 15/100 cubic centimeters. Let C be the volume of box C in cubic centimeters. Write an equation that could be used to determine the volume of box C. Okay, so it's saying here that the volume of box D subtracted from box C. So C when we subtract D from C, we get 23 and 14 centimeters cubed. And we know that box D has a volume, we know D is equal to 10 and 115 thousandths centimeters cubed. So it says let C be the volume of a box C in cubic centimeters, which we already did. We used C to represent C. Write an equation that could be used to determine the volume of box C. So what I'm going to do is I'm just going to take what we know about D and replace it with D. So our equation would be C minus 10 and 115 thousandths is equal to 23 and 14 centimeters cubed. I should have put centimeters cubed there too. So B says solve the equation to determine the volume of box C. So let's solve it. So C minus 10 and 115 thousandths. So what we're going to do is add 10 and 115 thousandths there, and then add 10 and 115 thousandths there. So that will get rid, these will cancel out, so we'll just have C by itself. And let's add these together. So 23 and 14 plus 10 and 115 thousandths. Gets us 33 and 255 thousandths centimeters cubed. So that would be, so the volume of C would be 33 and 255 thousandths centimeters cubed. All right, C. The volume of box C is 1/10 the volume of another box, E. So box C is 1/10, so this is 1/10 of box E. Let E represent the volume of box E in cubic centimeters. Write an equation that could be used to determine the volume of box E using the result from part B. So we know that this is 1/10 of E. So 33 and 255 thousandths is equal to 1/10 of E's volume. So D just wants us to solve that. So to get rid of 1/10 here, it's doing 1/10 times E. I'm going to do 1/10 divided by E. So we would do 33 and 255 hundredths divided by 1/10 is equal to 1/10 E divided by 1/10. And when I do 1/10 divided by 1/10 there, those cancel out. So we're just left with E. And 33 and 255 thousandths divided by 1/10. We did so much of this in 5th grade. So we're just going to shift the decimal, shift the values, the place values, one place to the left. So everything's going to go one place. All those values are shifting. So we get 332 and 55 hundredths is equal to E. Centimeters cubed is equal to E. And if you really wanted, you could also multiply it out. If you forgot about what we did in 5th grade, you could multiply that out and you would get the same thing.